Hi guys and girls on YouTube, welcome to my channel. In this video I'm going to be showing you a little valve amplifier I've been building over the last few weeks. Now this is a little unusual. It's not the sort of valve amplifier that you usually see on YouTube, and if you're one of these people that thinks a Mullard valve sounds better than a Mazda valve, then this video is probably not for you. So let's take a quick look. You can see I've covered some things up on the diagram and you'll see why in a minute. Let's take a quick look at the amplifier. It's not quite finished, although I have had it up and running and I'm hoping to finish it today. So let's take a quick look inside and then I'll run you over the technical details. So there's the amplifier in question. Let's just take a look underneath. Now this is a very small chassis box. And it's been a big job to pack all this in, and I also need to get another part in, which you'll see towards the end of the video, and we've run into a slight problem there. So let's take a quick look inside at the construction, and then I'll remove the piece of paper on the circuit diagram and you can see what makes this so unusual. So that's the triode pentode there, that's the input amplifier. The 47K you can see, that's the input to grid 1, the control grid. Then the next valve we've got is the audio amplifier, and the next valve there is the rectifier. That's the HT smoothing resistor. Now normally in an amplifier you would use a choke. Two reasons I haven't used a choke: we're running a very high anode current of 130 milliamps on the output valve. I don't have any chokes that big, and even if I did, there's nowhere to put one on here. So let's move over to the diagram and I'll show you some of the technicalities of this little amplifier. Now, like me, if you've ever repaired valve TVs, you'll recognise these two valves. That's a PL81 and that's a PY800, the efficiency diode. That's the line output valve. Now these were very, I think in the 1950s, this two pair valve lineup was one of the most common ones there is. So here, this is the basis of my amplifier. Now it's an all line output valve audio amplifier. So if we take a look at the triode pentode, the input section, I'm using a PCF802 valve, which in the valve TV, in its use in its day, was the line oscillator. Now we move over to the line output valve. I'm using, sorry, I should have said, if we move over to the audio output valve, I'm using a PL81, which was the line output valve. So that what makes this amplifier a bit special. It's an all TV line output valve amplifier. So let's move now to the circuit diagram for the rectifier and the heater supply. So once again, I'm using a very similar setup in a TV. The PY800, which in a TV was the efficiency diode, which returned excess line scan energy back to the power supply, in my amplifier now is actually rectifying the AC incoming mains. Now this is a very hardy valve. It has a maximum specified current of 175 milliamps, which makes it well suited to this application. So that's the valve lineup. We've got the efficiency diode PY800, the line output valve PL81, and the line oscillator PCF802. Now to get the heater supply, I've done just what they use in the valve TV. I've used a heater chain of power resistors. I've also built in a bit of a safety device. So what we're going to do, if we just use that on its own to power only 3 valves, the dissipation on this would be about 60 watts, which is far too high. I don't know what these resistors are rated at, but I don't suspect it's 60 watts. So what I've done, the same as they do in the TV, half wave rectify the heater supply, which cuts the dissipation in the dropper by 50%. Now the only disadvantage to this, if this diode shorts out, we're going to actually double the voltage across the heater chain, which will damage the valve. So as an inbuilt protection, I've put a BY133 there. Now in normal service that doesn't do anything, but if this was to short out, you'd have AC here. This diode would conduct heavily, and that through this resistor will blow the incoming mains fuse. So that's my safety circuit for the heater supply. So okay, that's enough of the diagrams. Let's move over to the amplifier, and I'll show you another little technicality of the amplifier. Right guys, so this is the nearly finished product. Hopefully it's going to be finished later on today, and then I can power it up and show it working. So your triode pentode, your line oscillator valve, that's amplifying the incoming audio. That's the PL81 line output valve. That's the Class A single-ended audio amplifier valve, and that's the efficiency diode acting as a mains rectifier. Now one of the quirks on this amplifier is it's an all live chassis. All the points are returned, all the earths are returned to this metal chassis, which makes it a little bit unusable, but we'll sort that out in a minute. So as you can see, I've got two live top caps. That's the anode for the PL81. That is the rectified mains on there. We're going to have about 270 volt on the cathode, and at the back there you can see the dropper. That is powering the heater supply. Now this is one of the most inefficient amplifiers you'll ever see. It draws a lot of current, it uses a lot of current, and also it produces a very little output. Normally I could push it to about 7 watts with distortion, but what I've actually done, if we move back to the diagram, in order to tame the thing and reduce the distortion and improve the linearity on the line output valve that shouldn't be amplifying an audio signal, I've earthed one end of the speaker transformer. I've taken a tapping off there, and what we're going to do is apply feedback straight from the output transformer to the cathode of the triode input. Now that will reduce, not only does it reduce the audio output, it also reduces the distortion, improves the linearity. So we're only going to get about 3 to 4 watts out of this. It would push to 7 if we disconnected the feedback at more distortion. So let's just take a little look around. Now another thing is, because we're running 130 milliamps of anode current, the output transformer would have to be a really meaty one. Now big output transformers are very expensive, and I don't have anything that would run that sort of standing current in Class A. So what I've done is I've just used an ordinary 12 volt transformer. Now the turns ratio of about 40 to 1, that's just about right, but also the application of feedback will make that transformer sound a little bit better than it actually should do. So let's take a look at the back. That's the dropper there. Now like I said, because it's an all live chassis, there's not a lot you can do with this. You certainly can't connect anything to it, although I have just connected it from my bench isolating transformer and connected it into my phone, just to test it out to make sure everything's working. So because it's a live chassis, what we're going to do is we're going to build into it a Bluetooth module. Now that means that with this plastic shaft we can actually build this into an old radio case. I've got 1 or 2 scrap valve radios, wooden cases. We can very safely build this in, and it will also give the appearance, so we'll have a Bluetooth radio, but it'll have the appearance and it'll have the smell of a real valve radio, because some of these valves, the surface temperature can be 200 degrees. Then we've got 30 watts dissipation from the dropper, we've got the heat from the smoothing resistor underneath. So when this is fitted in a radio and it's working on Bluetooth, it'll sound and it'll smell like a real valve radio. Now there's just one other thing here. If we look at the input capacitors from the rectified HT rail, you'll notice I've got the reservoir and the smoothing capacitors technically in reverse. The big one should be there, the reservoir, and the small one should be the smoothing. Now I've done that for a particular reason, and it's because the PY800, because it was never designed to rectify mains, the data sheet doesn't give a maximum specified capacitance output. So I've just had to guess at these, and that's why them two capacitors are in reverse. So yeah, okay guys, so that's the technicalities of the amplifier. Now the idea was to run the Bluetooth straight from the mains, like this, but I've run into another problem here. Dropping the mains down to 12 volt with this arrangement, we're going to dissipate just over 10 watts in this resistor. Now I don't think under there we can stand another resistor dissipating 10 watts, because we've already got one there dissipating 15, and it's going to be far too hot underneath for the electrolytic capacitors. So the plan is to just scrap that like that, and we're going to run the Bluetooth from a little 12 volt transformer. So alright guys, I'm going to stop the video here, and I'll tell you what, watch the video right to the very end, because I'm going to show you, when this is up and running, I'll show you something that I believe that nobody else has ever done. I've certainly never seen it on YouTube. So okay guys, I'll just stop the video and then we'll carry on with the build and come back to it. Right guys, well, I've run into a slight problem here. I'd like to say it's a slight problem, but it's actually quite a big problem. I can't get power to the Bluetooth module. So what I've done is I've penned up here a wattless dropper. I've worked out that I can get 71 milliamps using a 1 microfarad capacitor. I've made up this little module, wattless dropper. This will supply 12 volt straight from the main supply, and it's actually absolutely working fine, absolutely fine, but it won't work with a Bluetooth module, because when you connect the Bluetooth module to the power supply, because the Bluetooth module is earthed, it won't agree with the live chassis and it drops the voltage. So I've had to put plan B into operation. It's not what I wanted to do, but I've had to use a separate 12 volt transformer to get power for the Bluetooth module. Right, so as you can see, there's no room in here to fit another 12 volt transformer. In fact, there's no room to fit any transformer at all. So what I've had to do is I've had to mount it on the back of the cabinet here, which is also brought into another slight problem. I've mounted it on the back there, a little power supply, because of its very close proximity to the big output transformer. We're also getting some interaction and a slight mains hum now. But it's not the end of the world. Don't forget, this is a valve amplifier I'm making. So a bit of mains hum in the audio just makes it sound a little bit more realistic. It sounds more like a valve amplifier. So as you can see, the outside of the chassis is quite packed. We've got an output transformer, 12 volt transformer, we've got a Bluetooth module. That's the dropper on the back. Let's spin it around, and then what we'll do is I'll just stop the camera. I'll set the camera up on a tripod. We're connected up to a speaker here, and let's give it a whirl. And then if you stick with me to the end of the video, I'll show you what I promised you early on, which I don't think anybody's ever thought of before. Okay guys and girls, so the amplifier's set up. We're connected to a little speaker here. I've also had a quick look on YouTube for some, I don't know if you can see that, because we've got a bit of a, oh here we go, royalty free heavy metal music. So just give me a second, we'll just turn it on. That's the Bluetooth just connected. Just give it a couple more seconds for the valves to fully warm up. Yeah, you can hear the hum now, so it's ready to go. Oh, phone's gone off. Hang on. Here we go. Right, just give me a second and I'll just stop the camera, and I just want to show you this other interesting little thing. So here's a little question for you. How do you vary the output of triode pentode mechanically without using the volume control? Well, I'll just set this camera up on a tripod and I'll show you with this round magnet. Right guys, so let me just turn that down so you can hear what I'm saying. Right, I'll take the magnet, we'll turn the volume up on the amplifier, watch this. So that's cut off. So we turn the volume up a bit more. And that's the valve cut off. Right, let's make a tremolo effect. And there you go guys. So many thanks for watching, and subscribe to my channel for some more interesting things. That's the all line output valve Bluetooth audio amplifier. That's a PCF802. Let's see if we can turn this around. It's very hot now. PL81 and PY800. So yeah guys, thanks for watching, and please subscribe to my channel for some more interesting videos.